Good morning. So next we will solve this question, and the question is, if the potential function phi is log x square plus y square, we have to find out flux function psi and the complex potential function w, which is f of z. Since in fluid dynamics we know that the complex potential Fz is equal to phi plus I psi, and we have been given the value of phi. Then we have to find out the value of Fz as well the value of psi. So first we are going to find the value of Fz, which is complex potential. So we know that f dash z is equal to del phi by del x plus I del psi by del x, but we have only the value of phi, so we use CR equation to replace this psi x. So by CR equation number second, del phi by del y is equal to minus del psi by del x. Therefore this del psi by del x can be written as minus del phi by del y. Therefore we have this f dash z is equal to now del psi by del x minus I del phi by del y, or we can say it as phi x minus I psi y. So to get the value of f dash z, we have to differentiate this value of phi with respect to x to get phi x, and with respect to y to get phi y. So if we differentiate this with respect to x partially, it will be 2x upon x square plus y square, which is the real part, as you can see. And if we differentiate it with respect to y, it will be 2y upon x square plus y square, which is the imaginary part. So now we have the value of f dash z as 2x upon x square plus y square minus I 2y upon x square plus y square, but it is in the form of x and y. So to change it in the form of z, we have to use Milne-Thomson's method. I hope you have remembered the method that we have to just put x is equal to z and y is equal to 0. So by putting x is equal to z and y is equal to 0, we have the value of f dash z as 2z upon z square, which is equal to 2 upon z. This is the value of f dash z. To get the value of fz, we have to integrate this equation with respect to z. So integrate this equation with respect to z, the value of fz will be 2 log z. And we have to put a constant, but we have been given the real parts, so the constant should be imaginary. So the value of fz will be 2 log z plus IC. Now we have to find out its imaginary part. So since we have found that f of z is equal to 2 log z plus IC. Now we know that z is x plus iy, and log of x plus iy has separation formula half log x square plus y square plus I tan inverse y by x. So we place the value of log z or log x plus iy. So we have this equation. Now when we open the bracket, we have the real part as log x square plus y square and imaginary part as I 2 tan inverse y by x plus IC. So the imaginary part psi will be 2 tan inverse y by x plus c. So this is our question. We have found the imaginary part and the function both. Next we will solve one more question. So here we have to find out an analytic function fz whose value is equal to u plus iv, where u is the real and v is the imaginary part, when u minus v is equal to x minus y into x square plus 4xy plus y square. So let's start. Since fz is equal to u plus iv, then we multiply both sides by I. When we multiply both sides by I, we have another equation that I into fz is equal to. When we multiply this by I, it will be I square v, which is minus v as real part, plus iu. So after multiplying both sides by I, we have another equation. When we add these two equations, we have a new equation that 1 plus I into fz. when we add left hand side, and the right hand side will be u minus v plus I u plus v. Now let 1 plus I fz is taken as capital Fz, u minus v is taken as phi, and u plus v is taken as psi. So the equation 1 is now capital Fz is equal to phi plus I psi, which is a complex function whose real part phi, which is equal to u minus v, is given to us, and its value is equal to x minus y into x square plus 4xy plus y square. When we open the bracket, this value is equal to x cube plus 3x square y minus 3xy square minus y cube. So you take it as equation number 2. Now we have a question that we have to find out the value of capital Fz whose real part is given. So we use the formula of f dash z whose value will be equal to phi x plus I psi x, means del phi by del x plus I del psi by del x. But we don't have the value of psi. Therefore we have to use CR equation, that phi of y is equal to minus psi of x. So in place of psi x we can replace it by minus phi y. Phi x means del phi by del x, and phi y means del phi by del y. Since we are having the value of phi, so we differentiate it with respect to x to get the value of phi x, and we differentiate it with respect to y partially to get the value of phi y. So after differentiating and putting the value, we have the value of f dash z in the terms of x and y. So the value of f dash z is now 3x square plus 6xy minus 3y square minus I 3x square minus 6xy minus 3y square. But the value is in terms of x and y. So to replace it in terms of z, we have to use Milne-Thomson's method. So you remember Milne-Thomson's method, that we have to put x is equal to z and y is equal to 0. So if we put x is equal to z and y is equal to 0, we have value of f dash z is 3z square minus I 3z square, which can be written as 1 minus I into 3z square, which is value of f dash z. So to get the value of fz from this equation, we have to integrate both the sides with respect to z. So integrate both the sides with respect to z, the value of fz will be 1 minus I into integration of 3z square with respect to z. So the integration will be now 1 minus I into z cube. Since we are having our real part, therefore the constant should be imaginary. So we put a constant IC over here. So this is the value of capital Fz. And since capital Fz is equal to 1 plus I into small fz, so we can write it as 1 plus I into fz is equal to 1 minus I z cube plus IC. Therefore, by dividing both sides by 1 plus I, we can get the value of our function fz, which is equal to 1 minus I upon 1 plus I into z cube plus I upon 1 plus I into c. If you wish, you can rationalize it, otherwise it is okay. So we have solved 2 questions. Next we will solve some more questions. Till then you have to practice all the questions. Thank you.